This is the second tutorial in a series concerning how to utilize the Multisim program, the National Instruments Multisim program. In the first tutorial, the emphasis was placed on getting the parts from the various bins and placing them on the screen. In this tutorial, we will show how to connect the various parts in order to have a complete circuit. Now, prior to starting this recording, I have put all the components that we will need out here on the screen, and I have placed them exactly as they came out of the bins. I have not altered the locations or orientations of any at this particular point, so I can show that process as we go along. Now, the screen is perfectly fine as it is, but it might be easier to view if I change the size of the screen. So if you take the wheel on the mouse, you can do some adjustments here. It's a little bit tricky, but not too bad. We do a little bit of adjustment here. I'll make it a little bit larger and also move that down and move this along to the left. Okay, so we have a larger representation here of the various components. Now, let me do one thing before I start connecting any wires together. The first thing I will do is change the orientation of the 741 operational amplifier. This is the way that it comes out of the bin. And in fact, many references use that particular orientation. The orientation has the non-inverting input on the top and the inverting input on the bottom. Now, this is perfectly fine. However, many other references have the inverting input on the top and the non-inverting one on the bottom, and I personally prefer that for most wiring situations because it turns out to be a little bit cleaner for closed-loop amplifier configurations in many cases, not all, but in many cases when you have the inverting input on the top. So I'm going to change that orientation. The first thing I'll do is put the pointer on the op amp and do a left click, and that highlights the operational amplifier. The box around it means you have highlighted that particular component. Now, the way to change the orientation in terms of turning it over is to go up to Edit and then down to Orientation and then flip vertically. So I do that, and now the inverting input is on the top. You cannot do this by the other operation I pointed out in the first tutorial, in which you do several right clicks. You'll just wind up the same way that you started out. So let's leave that as it is, and anytime you want to deselect, just go outside of the area and left click, and the box is removed. Now, something else that's peculiar to this particular setup, and one that I must admit I've recently discovered as a neat way to do it, is to use the VCC and VDD power buses in order to create dual power supplies. There are four particular listings under the power sources that have the names VCC, VDD, VEE, and VSS. So as long as you need no more than 4 power supply values with respect to ground, you can use those 4, and you can change the values to anything you desire. They come out as 5 volts, at least some of them do. I'm not sure all 4 do, but anyway, the default value here is 5 for each of these. And I do need to turn this one over, the one on the bottom here. So I'm going to turn it over. First, I select it by clicking on it, and I can do the 2 steps on it, the Control R. So 2 Control R's, and it turns over, and I deselect. Now I'll go ahead and wire those up first. So to illustrate the wiring process, we do the following. First of all, these happen to be aligned perfectly, but if they weren't, it's a simple matter. You can use the arrow buttons on the keyboard to move left to right, or you can simply select and move like that, but it's probably easier to do it the way I was talking about, and that is to use the arrow buttons on the keyboard. So let's go ahead and wire up the one on the top. I'll change the values later, but I'll do the wiring first. So the way to do the wiring between 2 points, if they're aligned together, is to move the pointer to either one. It doesn't matter which one. And as you put it on the end of that connector, you'll see that it changes to hairlines. Okay, left click and then release. Now when you release and start to move with the mouse, you will see a dashed line, and that is a wire. And you move up to the connection end, and you see a red dot, and then you click again, and you have connected those 2 points together. Now I'll do that on the bottom. I'll start at this one, and left click, move upward until I reach the pin 7, and click on it. Pin 7, by the way, is the positive power supply bus, and pin 4 is the negative power supply bus. I'll change those values a little bit later, but let me go ahead and wire up the circuit while I'm at it. I need to connect R1 to pin 2, the inverting input. So again, I move the pointer to the point where the arrow, the hairlines come, left click, move over, and click again. That turns out to be pin 1 at the moment. We'll go back and possibly change some later, but that's okay for the moment. Now, in order to connect this one, I'll connect to this point here, move, well, let me get it straight here, left click, move over. Now you can make one turn without clicking it again. They always have to be right angles. So I'm going to move over to around here, and I'm not depressed. I could press if I wanted to, but I don't need to. For one turn, you can simply just move downward and then click. That becomes pin 1. Then over here, I'm going to connect to the output. So click. Now I made my one turn. Now you can only make that one turn without having to click again, but at this point I click again, and now I can move over to the output of the op amp and click again, and I have connected that resistor. Let me do the next several rather hurriedly so I don't run out of time. So I'll do this one, click, and I need to connect the ground here. By the way, the ground always becomes node 0. Let me pause for just a moment before I forget it and point out something that may cause a problem. It can be obscure if you don't catch it. And that is to show the node numbers. And in order to do that, up here under Options, you need to check on Sheet Properties and to make sure that net names, they use the term net for node, make sure that the net names has the Show All clicked here, because otherwise you won't see the node numbers. So we're okay. I can get out of there. Just check that when you start to create a circuit. And by the way, if you don't like an orientation, you can move it one way or the other, just selecting it. And sometimes this happens. Just catch the wire and move it out as necessary. No big deal. You'll learn how. The only way to learn this is just to play with it and get the sense of how to do it. And once you get the idea, it becomes fairly straightforward. Okay, the operational amplifier circuit is wired, but I want to go in and do some changes here. Definitely do some changes because I have a 1K resistor for both. I have R1 and R2. I have the voltages need to be changed along here. Now remember, pin 7 of the op amp is the positive voltage. I want to change that to 15 volts. So I'm going to double click on this particular bus and change that value to 15. Okay. Now on this one, I'm going to double click, and actually, I think I changed let me do that again. Okay. I want to change that one to minus 15. So I put a minus and a 15, and okay. So that one's minus 15. This one's plus 15. I can change the names if I so desire. For example, suppose I wanted to change this to V pos, representing V positive. I go back and double click on it, and on the label, it comes out as VDD. As you can see, I'll make it VPOS, VPOS. And I could do the same thing and change the name of that one, but I won't bother doing that. Suppose I want to make this resistor 20K. Okay, I double click on it, and I'll type, I could do 20,000 or just 20 little k. You don't put a space though. This is different than what you would do in a text. You simply put 20 and then k with no space between them, and that's okay. And suppose I wanted to make this one 5K. Okay, I can put in 5 little k. Okay, and that's 5K. So I have 20K and 5K. Suppose I wanted to change the name. Okay, I could have done that at the same time, but I didn't. But let's go back. And instead of the value, we move over here to the tab that's called Label. And let's say I want to change that to RF. So I have R, uppercase R, little k, or lowercase f. Okay. And then change this one to RI, label, and label, uppercase R, lowercase I, R sub I, and okay. So I have R sub I, 5K, R sub F, 20K. We are not going to connect the offset terminals. That's not necessary as long as you have reasonable size values for signals and so forth, but that can be connected in order to reduce the offset. We won't bother doing that. So let's see if I've done everything I need to do here to make the circuit work. I'll change the name of this one. I don't have to change the name, but I'm going to change that one to VNEG, for the negative power supply voltage. And I also like to use different names for the nodes. This one came out as 3. If I double click on it, I can change it to simply N. I like to use N for the input signal. Let's see, net name, so last name, not changing. Oh, yeah, preferred net name, N. See, I'll forget some of these operations, especially when I'm trying to make a recording. But the point is that you play around each time until you get what you need. That changed it to N. Let's do the same thing over here and change that one to out, of course. O-U-T for out. And I could change the name of this or change the value of it. In fact, I would overload the op amp if I kept that as 12 volts. Let's say I wanted 1 volt. Okay, that's 1 volt. And I think I've illustrated, I'm less than a minute remaining on this particular recording, but I think I've demonstrated to you how to connect the circuit. So we'll leave it at that.